Look at your hands. Right now, you are holding a piece of a star. The calcium in your bones, the iron in your blood, the carbon that forms the very framework of your body. All of it was forged in the heart of a long-dead star, in a cataclysmic explosion that scattered these elements across the cosmos. We are not just living on a planet, we are literal stardust, living remnants of the universe's most violent and creative process. And for our entire history, we have looked up at the sun, that giant ball of fire in the sky, with awe and mystery. But what if I told you that the greatest achievement of our species would not be to simply worship that power, but to recreate it right here on Earth? What if the key to our future as a civilization was learning to build our own miniature, obedient stars? This isn't a prologue to a science fiction movie. This is the quest for nuclear fusion. And today, we are not just asking if we can do it. We are asking the question that will redefine the 21st century and beyond. What if we master nuclear fusion? Oh, understand why fusion is so revolutionary. We must first confront the uncomfortable truth about our current existence. We are, fundamentally, a fire-based civilization. For millennia, from campfires to coal plants, we have relied on the same basic chemical process: burning things. We are burning the ancient, decomposed remains of forests and plankton, a prehistoric battery we call fossil fuels. This fire has powered our progress, but it is a primitive, dirty, and brutally inefficient fire. It chokes our cities, destabilizes our climate, and pits nations against each other in a zero-sum game for a dwindling resource. Even the clean alternatives have their limits. Solar and wind are fantastic, but they are intermittent. The sun doesn't always shine. The wind doesn't always blow. They are whispers of energy. What we crave is a shout. A constant, reliable, titanic source of power that can serve as the bedrock of a global civilization. And that shout, my friends, is written in the language of the stars. So, what is this language of the stars? It all comes down to a simple universe-altering equation. E equals mc, energy equals mass times the speed of light squared. The speed of light is a colossal number, and squaring it means that a tiny amount of mass can be converted into a staggering amount of energy. In the core of the sun, where temperatures reach 15 million degrees Celsius and gravity creates immense pressure, atoms of hydrogen are moving so frantically that they overcome their natural repulsion and smash into each other. They fuse, creating a new element, helium, and in that process, a tiny bit of their mass vanishes. It doesn't disappear. It transforms directly into pure energy, as per Einstein's law. This is fusion. Now, here on Earth, we can't replicate the sun's gravity. So, how do we create the conditions for fusion? We have to make the fuel even hotter over 150 million degrees, turning it into a fourth state of matter, a swirling, superheated soup of particles called a plasma. This plasma is so hot that it would instantly vaporize any physical container it touches. So, we contain it not with walls, but with an invisible force field bottle, powerful magnetic fields. This is the essence of our most advanced reactors, like the massive ITER project being built in France. It's a ballet of physics, engineering, and sheer human audacity, the attempt to create and cage a star. Let's fast forward. The year is 2045. The first commercial fusion reactor has achieved sustained ignition. The star is lit. What happens next? The change is not gradual, it is seismic. First, the energy revolution. The fuel for the most common type of fusion is deuterium and tritium, isotopes of hydrogen. Deuterium is extracted from seawater. Just 1 liter of seawater contains enough deuterium that, when fused, releases the energy equivalent of 300 liters of gasoline. The world's oceans become our universal, limitless fuel reservoir. The concept of an energy crisis is relegated to the history books. Energy becomes not just cheap, but so abundant it becomes virtually free. Think about the implications for every industry, for the cost of every product you buy. Second, the geopolitical reset. The map of global power, which for a century has been drawn over oil and gas fields, is completely redrawn. The strategic importance of the Middle East, Russia, and other petrostates undergoes a fundamental shift. Why fight wars over oil fields when your nation's coastline provides enough fuel for 1,000 years? Energy independence becomes an achievable reality for nearly every country on Earth. Fusion doesn't just power our grids, it has the potential to extinguish one of the primary sources of global conflict. But the story gets even bigger. With this limitless, clean energy, we can move from merely sustaining our planet to actively healing it. The environmental renaissance. We can deploy massive machines, powered by fusion, that do the unthinkable. They suck carbon dioxide directly out of the atmosphere. We can begin to reverse climate change, not just stop it. We can power massive desalination plants, turning oceans into fresh water and greening our deserts, ending water scarcity forever. We can synthesize clean fertilizers and fuels, closing the loop on pollution, the birth of a spacefaring civilization. This, for me, is the most thrilling part. Our current rockets are like wooden sailboats trying to cross the Pacific. They're slow and limited by the amount of chemical fuel they can carry. Fusion changes everything. A fusion-powered spacecraft could generate immense thrust for months on end, using minuscule amounts of fuel. A trip to Mars, instead of 9 months, we could be there in weeks. We could build permanent, thriving cities on the Moon and Mars, powered by their own compact fusion reactors. The asteroid belt, filled with precious metals like platinum and gold, becomes the new frontier for mining, ending resource scarcity on Earth. We are no longer confined to this pale blue dot. We become a true interplanetary species. So is this a utopia? Not necessarily. With such godlike power comes profound responsibility and equally profound challenges. What happens to the millions of people employed in the fossil fuel industry? We would need a global effort, a kind of societal retraining on a scale never before attempted. How do we ensure this technology is shared equitably? Does it become a tool for global unification, or does it create a new, even more dangerous divide between the fusion haves and have-nots? The technology to contain a star could also lead to advanced weapon systems. The same science that gives us limitless energy could be perverted into instruments of control. Mastering fusion is not just the ultimate test of our intelligence. It is the ultimate test of our wisdom. It holds up a mirror to humanity and asks us, are we mature enough? Are we wise enough to wield the power of a star without turning it upon ourselves? The equations are written, the physics is understood. The star is waiting to be born. The question is no longer can we. The question, the most important one we will ever answer, is this: what kind of civilization will we choose to build when we finally hold the fire of the sun in our hands?